Guys, in today's video, we'll be learning how to subtract binary numbers. Let's get right into it. Just like in addition of binary numbers, subtraction of binary numbers can be done using two different methods. Let's get into the first method. This involves performing the subtraction directly in base 2. So I'm going to write out the number 1, 0, 1, 1, 1, 1 in base 2. And then the second number under it, that's 1, 1, 0, 1 base 2. And then let's go ahead and subtract. 1 minus 1 will give us 0. 1 minus 0 will give us 1. 1 minus 1 will give us 0. 1 minus 1 will give us 0. And then since we don't have any digits here left, we'll just bring down these two digits, 1 and 0. So we have 0 and 1 in base 2. So this means that 1, 0, 1, 1, 1, 1 in base 2 minus 1, 1, 0, 1 in base 2 is equal to 1, 0, 0, 0, 1, 0 in base 2. So this subtraction is easy and straightforward, and that's particularly because we didn't have to do any borrows. Let's look at the second example that we have here. We have 1, 0, 0, 1, 1, 0 in base 2. Now we have to subtract 1, 1 base 2 from it. So draw a subtraction line. Now you have 0 minus 1, and this cannot go because 1 is greater than 0. So just like we'll do in our ordinary subtraction in base 10, that's of decimal numbers, we'll have to borrow from the number just before 0. We have 1 here. So we're going to come to 1 and we'll borrow. So if we borrow from here, what we'll have left is a 0. Now, because we are working in binary, which is base 2, whatever you borrow will be a 2. Just like when you are working in base 10, whatever you borrow, every if you come here, you borrow 1. When you come to this side, it becomes a 10. In base 2, if you borrow 1 from here, when you bring it to where you are borrowing to put, it becomes a 2, not a 1. So this is going to be 2. And 2 minus 1 will give us 1. 0 minus 1 cannot. So we'll come to the next number here and we'll borrow again. So if you borrow 1 from here, this is going to be 0. But what we have borrowed when it gets here will be a 2. Again, 2 minus 1 will be 1. And then I'm going to bring down the other numbers here. We'll have 0, 0, 0, and 1 in base 2. So this is how to perform subtraction directly in base 2. I think that the most important thing you need to learn here is when you have to do a borrow. Remember that anytime you borrow in base 2, it becomes a 2. Just like in base 10. Let's look at a short example of subtraction in base 10. Say you want to do 12 minus 9, for example. Now we know that 2 minus 9 cannot go, but let me make that 42 so that we can borrow from. We have 42 minus 9. 2 minus 9 cannot, so you come over to 4 here, you do a borrow. What will remain here will be 3. Now because this is in base 10, what you have borrowed is a 10. So when you bring that 1 here, you're going to get 12, not 1. Because if you had gotten a 1 from your borrow, what you get here will be 2 plus 1, 3. But the reason why when you borrow 1 from 4 and bring it here is a 12 because what you have borrowed is a 10. And 10 plus 2 will give you 12. In that case, you can say 12 minus 9 and you get 3 and bring down this 3 as well. That's why 42 minus 9 is 33 because in base 10, what you borrow is a 10 and the 10 plus 2 will give you 12. 12 minus 9 give you 3. So also when you borrow in base 2, what you're going to borrow will be a 2. I hope that makes sense and that makes for easy understanding. So this is the first method we use when performing subtraction of binary numbers. We're going to go ahead and try the second example using our second method. Now the second method involves conversion. We'll convert both numbers from base 2 to base 10 before we perform the subtraction. And then when we get our result, we'll convert the result back to base 2. This method is a bit lengthy, but if you know how to do your conversion very well and you have a problem figuring out how the borrowing works, you can go ahead and use this method. So to convert this number, I'm going to write out 1 0 0 1 1 0 base 2. I'll write the powers above this number. I have 0 1 2 3 4 and 5. I'm going to start my expansion down here just so I have enough room to do that. So this is going to be equals to 1 times 2 raised to the power of 5 plus 0 times 2 raised to the power of 4 plus 0 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. So what we are trying to do is to convert this number to base 10. If you're not already familiar with how to convert numbers from base 2 to base 10, please do check out our video on conversion from binary to base 10. So next we are going to deal with the power here. This is going to be equal to 1 times 2 raised to the power of 5 is 32 plus 0 times 2 raised to the power of 4 will be 16 plus 0 times 2 raised to the power of 3 will be 8 plus 1 times 2 raised to the power of 2 will give us 4 plus 1 times 2 raised to the power of 1 will be 2 plus 0 times 2 raised to the power of 0 will give us 1. Next, we're going to multiply. We have 1 times 32, which will give us 32, plus 0 times 16, which will give us 0, plus 0 times 8, which will be 0, plus 1 times 4, which will give us 4, plus 1 times 2, which will give us 2, plus 0 times 1, which will be equals to 0. Next, we are going to add. We have 32 plus 4, which is 36, and 36 plus 2, which will give us 38. Next, we are going to convert the second number, which is 1, 1. So I'm going to go ahead and write 1, 1 in base 2. We'll indicate our powers above each number. We have 0 and 1. It's pretty short. We have 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0 This is going to give us 1 times 2 raised to the power of 1 is 2 plus 1 times 2 raised to the power of 0, which is 1. Next, we'll go ahead and multiply, and this is going to be equals to 1 times 2 is 2 plus 1 times 1, which will give us 1. And we have 2 plus 1 to be equals to 3. So now that we've converted both numbers, we're going to go ahead and subtract. We can see that 1, 0, 0, 1, 1, 0 in base 2 minus 1, 1 in base 2 will be equal to 38 minus 3, which is equals to 35. Now we have our answer in base 10. What we have to do is to convert the answer, which is 35, back to base 2, because the question was given to us in base 2. The answer have to be in base 2 as well. So we're going to convert 35 to base 2. If you don't already know how to do this, do well to check out our video on conversion from base 10 to base 2. So to do this, we're going to divide 32 by 2 while we store our remainder. So 32 divided by 2 is going to give us 17, remainder 1, because 17 times 3 is 34. We'll divide 17 again by 2. 17 divided by 2 will give us 8, remainder 1. 8 divided by 2 will give us 4, remainder 0. 4 divided by 2 will give us 2, remainder 0. 2 divided by 2 will give us 1, remainder 0. And 1 divided by 2 will give us 0, remainder 1. Now remember that we write our answers in this direction from down to up. So this means that our final result will be equal to, I'm just going to write 1, 0, 0, 0, 1, 1 in base 2. So if you check this out, you're going to see that it's the same as the answer we got when we used the first method. So I just advise my students to use whichever method works best for them, but you also have to be conscious of time, because this method is quite lengthy and takes a bit of time to do. So that's it on our lesson on subtraction of binary numbers. If you enjoyed this, please check out our next video on multiplication of binary numbers. As always, I've got a bit of classwork here for you to do. Do well to try this out in your free time, and always feel free to submit to the email on your screen. I'll be happy to look over them and send you feedback. That's it, guys. Thank you for watching this video. Please do well to like, share, subscribe, and turn on our notification button so you know when we upload a new video. I'll see you in the next one. Bye.